Hello everyone, welcome back to my YouTube channel. So today the topic is Zener diode. So in diode, we are having two cases. It can be used as forward biased as well as reverse biased actually. So if it is forward biased, it can be used as a normal diode, that is PN junction diode. And if it is reverse biased, it acts as a voltage regulator. Yeah, so then now here this is the symbol of the Zener diode. So as we already know, the symbol of the PN junction diode is this one, and the symbol of the Zener diode is this one. So the Zener diode can also be used as in forward bias as well as in reverse bias situation. In forward bias, yeah, I already told you, it acts as a exact PN junction diode, and in reverse bias it acts as a voltage regulator. Yeah, so now we will go for the circuit of the Zener diode. So this is the circuit in which the Zener diode is used. So this is Zener diode, and it is used, in this case it is used in reverse biased condition. So this is V is the voltage which is applied, and this is a resistance which is connected, and this is Zener diode. So it is used in reverse bias because this is positive terminal of the battery, this is positive, and this is negative terminal. So negative of this battery is connected to positive of the diode, and positive is connected to negative of the diode. So this is reverse bias situation. In this case, it will act as voltage regulator. Okay, so this is one more the explanation of this one. So we can say the PN diode, when it is connected in reverse bias. Again, the same scenario, I am trying to explain it in another way. So this is PN junction diode, it is connected in reverse bias. Yes, this is a Zener diode. So here what happens is, as it is reverse biased, this is the barrier will be more in case of reverse biased situation. So if barrier is, because of this barrier is more, in order to use Zener diode, as what we will do is, P and this N region we will dope heavily, so that there is a sharp depletion region will be there. So that what will happen is, whenever the voltage reaches the Zener voltage, regarding Zener voltage I will be explaining you here later. So in Zener voltage, what will happen is the breakdown will happen, and this barrier will be going, and the conduction will be started. I mean, the maximum current flows in the circuitry. Yes. So this is about the Zener diode. So in this Zener diode, we will study regarding the VI characteristics of the Zener diode. In this Zener diode, this is the normal diode which you already know it. This is FB, this is forward biased, and this is reverse biased situation. So in forward biased, as V increases, I also increases. So this is forward biased situation. But we are not concentrating on this part now, as we are using Zener diode in reverse biased condition as a voltage regulator. So now, so this is reverse biased situation. This is I, and this is V. And as the voltage is increased, there will be some current flowing, which is reverse saturation current. So at one point of time, every Zener diode will be having one Zener voltage. So that Zener voltage is indicated here as Vz. I hope you are able to see. Yeah. So this is Vz. It is a Zener voltage, and once the voltage reaches up to Vz, during that condition, the maximum, there will be a breakdown, and there will be maximum current flowing through the circuitry. So this is the maximum current which I am trying to explain. So this is Vz and the resulting Iz. So this is resulting outcome current, which is Iz. So now I will, so this is under reverse biased condition. So now I will try to explain you regarding the operation in more detail. So this is we will just learn with the help of this small circuitry. So this is V in voltage. So this is V in voltage. So this is unregulated power supply. So that means the power supply is not exactly fixed. It varies sometimes. Let us say if it is 10 volt or 11 volt or 12 volt, then sometimes it fluctuates. So that is unregulated power supply. And here this is Zener diode, which is having Vz as the voltage, Zener voltage. And once the current flows here, until it reaches Vz, the current flow will be less. Once it reaches Vz, there will be no further change in the voltage across the Zener diode, and maximum current flows through the circuitry, which is indicated as IL here. So this is load resistance. And one thing which why Zener diode is called as voltage regulator. So the main reason is once the voltage which we are applying reaches the Vz voltage, that is Zener voltage, then there will be no further increase in the Zener voltage. So that means that the voltage is regulated. So that's why this is called as the voltage regulator. So Zener diode can be called as voltage regulator, because see, as you can see, we are applying unregulated power supply. We are receiving exact power supply. If we are applying some 12 volts, we are getting only 10 volts, as Zener voltage is 10 volts. If it is of 10 volts, we will be getting maximum 10 volts. So this is how it operates. So this is regarding the Zener diode, and as I already told you the application, that is Zener diode acts as a voltage regulator. It can be used wherever we need to, as in voltage stabilizers it will be used, in industrial applications where voltage fluctuation is not expected or not required, we will be using in this situation. Yeah, so this is regarding Zener diode. Thank you for watching. Please subscribe to my YouTube channel. Thank you.